So let's begin. So today, what we're going to be talking about is the number E. Okay? The number E and exponential growth and decay. All right? Well, here's what the number E is. It is going to be E is equal to 1 plus 1 over infinity to the infinity power. Now, since we can't get a number that big, all we get is a decimal, right? In our calculator, we can use the biggest number, biggest number, biggest number. But infinity really isn't even a number, right? So what we can get, the best we can do is get a decimal for E because we can't get to infinity, right? But that's what the number E is. The number E is all about continuous growth or continuous decay. All right. So, if I want to graph y equals e to the x, then I'm going to plug in some numbers. I'm going to do, first of all, e to the 0, e to the 1, e to the 2, e to the 3, and that should give me some numbers, right? In my calculator, I'll show you. And you don't have to use mine, but they're good calculators. Right here, above, right by the 7, is this e to the x. That's the button I want to use. Is that e to the x button right there? Okay. So I'm going to push e to the 0. So I go to that button, I go e to the 0, and I get 1. Okay. I'm going to go e to the 1 power, about 2.7. I'm going to go e to the 2nd power, about 7.4. And then I can go e to the 3rd power, and I get about 20. So I just used my calculator, so I'm probably going to need to go maybe 10, 20, and just estimate, okay? Just estimate. So e to the 0 is about 1, maybe about there. E to the 1 is about 2.7, about there. 7.4, about there. About 20. So it's going to look like our Skittles. That's what we did with Skittles. It looks like our Skittles. What I don't have is negative numbers, but I can put those in my calculator also. Am I going too fast? I'll wait for a second, okay? So I don't have my negative numbers, but I can also do my negative numbers. E to the negative 1 and e to the negative 2 might be enough. So I go e to the negative 1 is about 0.6 maybe. I don't know, about 0.6, or 0.4. Then e to the negative 2, about 0.1. Okay, so it's getting smaller. We talked about how it has this invisible boundary line that it gets closer and closer to but never touches, and that's called my horizontal asymptote. Okay, that's at y equals 0. I'm going to connect the dots because it's not like Skittles. I mean, I can put in any number, right? There it is. Domain. Well, let's go back to what domain means. The real meaning of domain is this. The real meaning is what are the values of x's? What are all the values of x's? An easy way to see domain on a graph is how wide is it? Okay, that's your x's, right? It's forever wide, isn't it? It goes forever this way, and even though it's going up, it's always going over, right? And not only that, I can plug in anything I want. You guys agree? So domain is, what are the x's? Anything I want, or all real numbers, okay? So domain's easy. You guys agree?
Domain is simply x equals all real numbers, okay? Now the range
is all y values. Well, when you graph it, we can see it like, well, how tall is the graph? Well, there's no graph down here, right? There's no graph down here. But it starts here at this invisible line, goes up, right? But it never touches the line. So it never equals 0, does it? But it's bigger than 0. So we write y is greater than 0 for the range.
So the range, we're going to go y is greater than 0. Okay, how am I doing? Show me thumbs up.
Just greater than or equal?
Not equal to, because it
Never touches 0. It's like me going to the door, right? Half of a half of a half of a half. I'm never going to get there, am I? It's never equals 0. Good question. Thumbs up so far? Okay, you're doing a great job of paying attention. Thank you.
Now, on example 2, what we want to do is just take this graph and move it up 2, or move it down 2. So we're going to do a translation. We're going to move it down 2. We can also use Desmos, but I think I can do it faster just by going -1, -2. So at -2, I'm going to put my asymptote. So I'm just bringing the whole graph down 2. So
Taking this graph here, it just went down. That's why that's it. Right? Now let's take this point and bring it down as well. Except for having to go through at 1, it's going to go through at 3. But it's going to go through here. Actually, it's going to go through 1, but it's going to come down. It's going to go down 2. It's got to go down 2. 1, 2. So it's going to go down right. Down 1, 2. Right? Goes right there. Does that make sense? Take the whole thing down 1, 2. So I'll put right there. Okay.
So I graph it in. Okay, now, easy question. What's the domain? What's the domain? Good, it is all real numbers. Everybody agree? Domain? X equals, and I use the cursive R for all real numbers. It's just easier for me. What about the range? Yes, yes. Yes, perfect. Y is greater than -2. You start at a height of -2 and go up, but you never quite reach it. How am I doing? Thumbs up? Good. That's not so bad. Now, the next one, I might just want to use Desmos to take a look at it because I'm a little confused. What does this look like? So I'm going to go ahead and go to my Desmos. Why not, right? So go to my Desmos. And I'm going to go y equals my 2, and you have an e in here somewhere. There's my e. Do you see where I found my e in Desmos? To the power of, hold on, to the power of a -0.2x. All right.
Well, there's a couple of things that actually make sense to me. This 2 right here makes sense. Right? See that right there? That 2's got to be there because that's got to be the starting point. Like we graph, right? That 2 makes sense. That 2 here would be 2 here. And because it's negative, it's decay. It goes down, okay? So let's go ahead and put that in there, okay?
All right, this is not so bad. So I'm going to go 1, 2, and I don't have to have a lot of points, just the general shape. Okay, let me say it again. I don't need a lot of points. I need a couple of things. So on a test, I need 3 things from you, okay? I need 3 things from you on a test, okay? I need the right shape, okay? Here's my shape, okay? I need the right shape. I got the right shape, right? I need a starting point, right? And I'd like to have the asymptote, because it shows a boundary line, right? It shows it's not going to cross over and go further down, okay? Now, it asks a weird question, but it's not going to be too hard with my calculator. It says, write in the form of A times 1 plus R, okay? So, what is E to the negative 0.2? I'm going to find out what E to the negative 0.2 is, and then I'll be able to write it like that, okay? So I'm going to use my calculator, and I'll say, okay, what is E to the negative 0.2? And I get an answer of about a 0.818. Okay. So, if I had a 1 minus a 0.181, and I just subtracted 1 from that, I'd have it in the form they want. Now, this is a question I'm not going to ask on any test, but your homework will. So I want to go through it, okay? Don't sweat this. This is something you'll see in pre-calc. So I don't sweat yet. Not yet. Okay. Okay, ready to turn the page? So far not bad. You guys see the shape just like our Skittles? They look like skeeters, don't they? Right? Okay, here comes the easy stuff. Okay? Easy stuff. Okay, give me an answer. E to the what? E to the what power? E to the 10. Everybody look at that. E to the 10? I agree with Alex. Do you see it? How did Alex get 10? That's it. I'm going to get a 9e to the 15. Oh my goodness gracious, who said that? Thanks, Kestrel. I made a mistake. Kestrel, thank you. Thank you, thank you, thank you, Kestrel. Thank you, Kestrel. That was my mistake. Thank you. Thank you, thank you. Okay, now, where did the 27 come from?
3 to the power cube.
Where did the 15 come from?
35 plus 3.
Easy, right? Okay, what do you think about this next one? What's the answer going to be?
Right.
3e negative 2 is correct, or, yes, or 3 over e2. I'll take either answer, okay? Now, banking formulas are also used in exponentials, okay? So one banking formula is this, a to the t, and they're easy to use. We just have to have the right formula. P, and we're going to go 1 plus r over n to the nt. So write that formula down. Okay, write that formula down. Write that formula down. Write that formula down. So this formula is used all the time in banking. I understand that most of them just use a computer or a calculator that just does it. But it's actually, this is the formula that's programmed into their little calculator. So when you sit down with the banker, they'll go da-da-da-da, boom, right? But the formula is this formula, okay? So we want to buy a house, you need a loan or whatever. It's already in their calculator, but this is the formula they use. Okay, so ready? Now look at this, 4,000? That was right there. That's my principal. In this example, okay? So it's called your principal. It's what you start with, okay? Put in 4,000, okay? 4%. 0.04 goes there, right? Not 4%, but 0.04, right? Because we move decimal over 1, 2, right that? N is the number of times she's going to compound it in a year. Well, she's going to compound it
quarterly, which means it's gonna be compounded 4 times a year, they give you interest. And then essentially make interest on your interest rate. So let's say you make 5 cents on the first quarter, and that 5 cents goes into your bank account, and you get to make interest on that interest. See how it works? So it's a good thing, right? Now, so then my 4 goes here because of quarterly, and my 4 goes here because of quarterly. And then how long is she gonna keep it in the bank? 5 years. So let's see how much money Keegan would have gained if she left her bank in there for 5 years, compounded quarterly, okay?
So we're gonna go and take calculator. I'm gonna go 4,001 plus 0.04 divided by 4 to the power of 4 times 5. Okay, see if you can get that in your calculator, just like that. Okay, that's my answer. See if you can get that answer. Okay, can you get that answer? So Keegan now has $4,880.76 in the bank, okay? So she made about $800, right? 880 bucks. It's not bad. Now, continuous interest.
Let me erase this. So when you see the word, and I said earlier, when you see this word continuous, you think E, all right? You think E, you think the number E. Whenever you see this word continuous, you gotta think of the number E. So I'm gonna give you a new formula. So write this formula down.
We're going to write A of t equals P e to the RT, all right? If it's continuous, you want this formula, okay?
So then, this bank is gonna put, did you guys write that down? You guys write this down, write that down? Write this one down?
You expect us to understand this?
Yeah.
A hall.
I'll go through it again, because I do expect you. I know you can. It's just put numbers in places and push buttons, that's all. Okay? So, 4,000. I'll wait till you guys get done writing this down. Okay, ready? 4,000 goes there, right? So we're going to put 4,000 there.
I'll calculate the interest.
E is my number in my calculator, right? R is 0.04. And T in this case is going to be 5 years. So in my calculator,
We're just going to type in, we're going to go 4,000. We're going to go E, my E button's there. 0.04 times 5. And she makes a little bit more money because it's compounded more often, right? So this time she makes about $4,885.61. Yeah, $5 more, right? Yeah.
okay, so Luke, yeah, absolutely. I know you can do this. So we're just plugging the numbers in the formula and using our calculator. That's all. Plugging the numbers into our formula and using the calculator. That's all. Okay. Principal, P. How much money did you put in? Wow. 1. Always 1. You know why you need 1?
No.
Great example. Okay, so just here, listen for a second, okay? I go to the bank, I got $1,000. I give my $1,000, they say, great, I'll give you 5% interest, okay? I come back in a year, I give them $1,000, right? They hand me 20 bucks. I go, where'd my 1,000 go? If you don't have the 1, you don't get your original money back. Gotta have the 1, right? If you don't have the 1, you don't get your original money back, all you get is your interest. So the 1's really important, isn't it?
Fit, bro.
Right?
Money number, we give back.
Okay, so homework today, page 141. 1 to 13 all, it's not that many, and a lot of it's pretty easy. You may need to do some graphing, but you've got a calculator or Desmos to